Hello students, welcome to the first video of this new playlist. So in this playlist, I will upload solution videos of each of the question from the most recent past paper of Statistics 2, which is the October 2024 S2 paper. So under this playlist, you will find total of 7 videos where I will solve each of the question of this paper. So this paper has total of 7 questions. So for 7 questions, there will be 7 videos under this playlist. So this is the first video of this playlist. So in this video, we will be solving the first question of Statistics 2 October 2024 paper. So let's get started with the first question from S2 October 2024 paper. So here you go. You can see the first question of this paper. So here the question says, during an annual beach clean, the people doing the clean are asked to conduct a litter survey. Okay, the cleaner are asked to do a litter survey. Okay, at a particular beach clean, litter was found at a rate of 4 items per square meter. Okay, so litter were found at a rate, it's what, at a rate of what, 4 items per square meter. Fine. So part A is asking here to find the probability that in a randomly selected area of 2 square meters on this beach, exactly 5 items of litter were what, found. Okay, so let's consider. At first we need to figure out how the number of litter, the number of items in the litter that has been found, it is how it is distributed. So look at the pattern of the question. The question says what? The litter was found at a rate of 4 items per square meter. That means it is found at a constant rate, right? And it is what? Per square meter. This is a fixed interval, right? And the number of items that would be found, it will be found independently and singly, isn't it? Because these are discrete data, isn't it? So that means this the number of items that would be found here, it is what? Distributed under which distribution? Normal? No, definitely no. Binomial? No. It is what? Poisson. Because in Poisson distribution we know that the outcomes are found at a constant rate. The outcomes occurs at a constant rate. Okay, so at first write the distribution of the data. Okay, we consider this as what? X. So X is distributed with Poisson distribution, and hold on, we know that for Poisson distribution the rate it is dependent on the what? Size, or you can say it is dependent on the interval. So in the question, they in the passage, okay, they said 4 items per square meter, right? So per square meter 4 items are found. That means in 2 square meters, 2 times 4, that is 8, because the rate, it is dependent, it is proportional to the size of the what? Size of the sample. Okay. Okay, so Poisson, it is what? The mean would be 8. Okay. Okay, so let's write it down. What is X? What is X representing? The number of items, of litter found in what? 2 square meters, right? In 2 square meters. Fine. Okay, now we need to find out the probability. They wanted exactly 5. X equals to what? 5. Okay, so we know that the formula for finding the exact probability in Poisson distribution, it is E inverse lambda, whereas lambda is the mean, okay, times lambda to the power x, where x is the number of what? Number of outcome, Okay, that is what lambda is 8 to the power 5 over the x factorial, that is 5 is the number of outcome, that is x what factorial. Okay, so let's use the calculator and figure it out the value. So 8 to the power 5 times e inverse 8 divide what 5 factorial. So 5 factorial gives us 0. Okay, it gives 0.0916036 Okay, so we can give the answer to three significant figures. So that would give you 0.916. This is up to three significant figures, and that's the probability that the part A has asked for. Fine. Okay, next is part B. In part B, the question says, of the litter found on the beach, 30% of the items were what? Face masks. Okay, so part B is asking to find the probability that in a randomly selected area of 5 square meters on this beach, more than 4 face masks were found. Okay, so if you see the question, if you see the percentage 30%, like watching this percentage, you might think that this is distributed under a binomial distribution, but not, it's not working like that. It says 30% of the items that has been found. Okay, it is what? Just face masks, that's it. For binomial distribution, we need to have what? A fixed number of trials, or fixed number of what? You can say sample. A fixed sample we would need here. But here it is just saying that 30% of the face masks, 30% of the items that has been found, these are what? Face masks. Okay, so it is still Poisson distribution, definitely. Okay, so since in Poisson distribution the what mean, it's proportional to the interval, so that means for 5 square meters the mean would be how much? It would be 5 times 4, right? Okay, so for part B, 5 times 4, it's the mean of items of litter that has been found. This is 20, that would be 20. So out of 20 items, how much is face masks? 30%, right? 30% of the items that has been found, these are what? Face masks. That means we can consider this as y variable. So y, it's distributed, look, mean for face masks, that would be lambda equals to what? 4 times 5 times what? 4 times 5 of that 30%. Okay, 30% is what? 3 over 10. So that would give you 20 times what? 20 over 10, this is 2 times 3, this is what? 6. So lambda is what? 6 here. So what does y represent? Y is basically y it is representing what? Number. This is the number of items that were face masks. Okay, face masks in how much area? In 5 square meters. In 5 square meters. Okay, fine. Now we just need to find out what? We need to find out more than 4. Okay, so that is more than 4. That means what? Probability of y greater than 4. That means what we need to do now? Y more than 4. Okay, that's fine. But now if you want to use the distribution table, the cumulative distribution table, we need to make it in the form of less than or equal, right? So 1 minus probability of y less than or equal what? Y 4, y equals to 4, it's not included, right? They wanted just more than 4. That means 4 is not included. That means if we want to get more than 4, we need to subtract less than or equal what? 4 from what? 1. Okay, so now how can you get that probability? Just have a look. I'll show you definitely. This distribution table, the cumulative distribution table, it will be given in the formula booklet. in the statistics 2 part, S2 part. Okay, so 6. So how to how to work with the table, I'll show you definitely. The first column, the first row, it shows the values for the lambda. So lambda we got 6, so it's up to 5, so we need to go to the next one. Here you got 6. Okay, lambda is 6. So under this column you will have the cumulative probabilities. So we want to have y less than or equal 4, that means this is that one. Okay, this table shows probability of x less than or equal x. Okay, the probabilities for cumulative probabilities for x less than or equal x. So we got our desired, our required probability. This is what, 0.2851. Okay, 0.2851. Okay, so this is 0.2851, we need to use it there. So 1 minus what, 0.2851, 1 minus 0. Okay, 1 minus 0.2851, 0.2851. So what would be the value? 1 minus 0.2851, that would give you 0.7149. Okay, this is 0.7149. So you can round up to 3 significant figures, that is 0.715. That's it. And that's what exactly part B has asked for. Fine. Okay, next is part C. In part C, the question is asking to use a suitable approximation to find the probability that in a randomly selected area of 20 square meters on this beach, less than 60 items of litter were found that were not face masks. Okay, so we need to use approximation. Okay, we will be considering the approximation later on, because at the beginning we need to do some other works here, because here the question is asking that we need to find out the probability of less than 60 items of litter that were found not face masks. Finding face masks, it is what, 30% that we had in part B, right? So not face masks, this is how much? 0.7, that is 70%, right? So at first let's find out the mean for 20 square meters. Okay, for 20 square meters, and then we have to consider the approximation. Then we have to pick which one would be suitable approximation according to the situation. Okay, so for part C, at first find out the value for what, lambda. Okay, so lambda would be what, 20 times how much, how many, the mean rate was 4 items per square meters. Okay, so 20 times 4, so this is the total number of items, total number of what, items per square meter. Sorry, in 20 square meters, this is what, total number, 20 times 4, right? So this would be 80. And then out of this 80, what percent is not face masks? This is 70%. So 70 over what, 100. So the lambda would be what, 20. So this is 7 over 10. So 20 over 10 is 2. So 2 times 4 is what, 2 times 4 is 8, and 8 times 7, that would give you what, 56. So lambda is what, 56. Okay, now consider this as, we can consider this as L, let's say liter items. Okay, L is distributed, it's still Poisson, because what, we just found that out of the litter that has been found, how many are not face masks. Okay, and its mean is basically what, 56. Okay, now consider the approximation. 56, if you check out the cumulative distribution table for Poisson distribution, its maximum is up to 10. So 56, definitely it's outside the lambda value that is given in the table. So we need to definitely do what approximation here. So which approximation would be valid or would be perfect in this case? Definitely we have to use what? Normal, this normal approximation. Why? Because for Poisson distribution we know that the mean and the standard deviation are equal. Since mean and standard deviation is equal and the value for lambda it is greater than 10, that means normal approximation would be perfect in this case. Okay, so we can approximate it using what? A z distributed normally with mean 56 and standard deviation is it's what? It's also what? 56. Okay, so standard variance, okay, standard deviation is equal to the mean. Okay, so 56 squared. Okay, so this is the what? For normal distribution, not 56. 56 square would be a very large value. Okay, for Poisson distribution the mean is equal to the variance. Okay, so that means it will be just 56. Mean is equal to the variance of the data. Okay, that's why 56 56. Okay, so what does it represents? L it represents the number of litter items found in how much area? In 20 square meters. In 20 square meters that were what? That were not masks or face masks, isn't it? Face masks. That's it. Okay, now it's time for finding the probability. They wanted less than 60 items of litter. Okay, less than 60. So less than 60 means probability of L less than 60. It can be approximated using probability of Z less than what? Less than 60. Okay, now we know that. Now this is very important concept. Okay, we are approximating a discrete variable, a discrete distribution using a continuous distribution. Normal distribution is a continuous distribution. So in that case, for approximating a discrete distribution using a normal distribution, definitely we will need to do continuity correction. Okay, so in that case, what would be the continuity correction? Probability of z less than or equal what? It's less than, right? It was just less than 60. That means 60 is not included. So what we will do? We will subtract 0.5 from 60. Okay, that's why it would be 59.5 because 60 is not included. That's why we have to subtract 0.5 and make the inequality less than or equal. Okay, this is the process for doing continuity correction. So now standardize, because we need what? To find the probability using normal distribution. So 59.5 minus mean is how much? 56. 56 over the standard deviation is what? Square root of 56, right? Okay, so the value would be z. Okay, z less than or equal 59.5 minus 56 over square root of 56. So this is basically square root of 14 over what? 8. Okay, now we need to find out that probability. So it is basically 0.468. If you have classwiz fx991ex calculator, then you can use the normal distribution function, okay, to find out the probability. If you don't have, then you can find it out from the distribution table. I'll show you definitely both the process. So it is 0.468, where it is 0.47. okay, 0.47. This is 0.47, which is 0.6806. Sorry, 0.6808. Okay, so let's use the normal distribution from the calculator. We got 0.6808 here. Now let's check it out using the calculator. So go to mode and then go to distribution by pressing 7, and then we need to find out normal cumulative distribution, that is second option. So lower limit would be negative infinity, okay, because we have to consider the area under the bell curve from negative infinity to the upper limit is what, 0.47, or the answer, okay, square root of 14 over 8. Okay, so sigma is fine, sigma is 1 there, mu is 0. Okay, everything is set. So 0.680000 something, that means the value should be, it should be 0.6800. the exact value we got from the calculator, it is what, 0.6800. so this is 0.6800. so the answer, the exact value, if I write, it would be 29736. okay, so we can round it to what, 68068, because 0 writing 0 and not writing 0, this is no effect, because after decimal 0 has no effect. Okay, so sorry, so we got the probability for part C, which is what, 0.680. okay, so that's the answer for part C, and that's the end of the first question from the October 2024 Statistics 2 paper. Fine.